Alrighty, you guys. Today we are talking about combining like terms and adding and subtracting polynomials. Okay, so last time we talked about coefficients, terms, constants, and variables, right? What makes up these mathematical sentences, whether they're equations, expressions, inequalities, all that good stuff. So today we're mostly going to be dealing with expressions, okay? We're not solving anything, so that tells us it's not an equation or an inequality. Okay, so first, let's actually define what a term is. Okay, so a term is a piece of a mathematical sentence separated by addition and subtraction signs. And subtraction signs. Okay, so that's what a term is. We learned that last time. Okay, so what makes a term a like term? Because you guys know that we can only combine terms, we can only simplify them if they are like terms. Okay, so a like term has to have the same variable and that variable has to be to the same power. So same variable and to the same power. Okay, so same variable, same power makes it a like term. Okay, so let's look at number 2. We'll zoom in for you guys. Number 2. So it's asking us to simplify the expression, right? We don't see any equal signs, so we know that this is an expression. So in number 2, we have two terms, right? 5p and 5p. So are these guys like terms? Do they have the same variable, same power? Yes, they are. They both have a p to the first power, p to the first power, right? So we identify, are they like terms? Okay, once we identify if they're like terms or not, then all we have to do is look at the coefficients. Okay, so once we look at the coefficients, think of it like this. So 5 pumpkins, since it's fall. So we have 5 pumpkins plus another 5 pumpkins, right? The variable is just representing a value. Okay, so if we have 5 plus 5, or 5 p plus 5p, how many p do we have? Okay, we have 10p. And there we go. That is simplified. Okay, so are they like terms? Look at coefficients. And then once you look at the coefficients, just make sure you attach that variable at the end. Okay, in fact, we'll write that down. Attach variable. Right, you couldn't have just said 5 plus 5 is 10. 10 would have been your answer. It's 10p. Okay, so let's look at number 3. Okay, are these guys like terms? I have two terms here. Are they like terms? Yes, they are. Okay, they both have an n to the first power. So we can just say negative 8 plus 6, just looking at their coefficients. What is negative 8 plus 6? Okay, we get negative 2. All we have to do is put the n back on. And simplified. Okay, so let's look at number 4. So where are my like terms on number 4? So I see that I have one term with the variable, that 10x, but then I see just 1 and 3, right? So who remembers the word from last time where a number is all by itself? It starts with a C. Okay, it's not a coefficient because we know coefficient's in front of the variable. What is the word for a number that is just by itself? Okay, that's a constant, right? So let's make a little note of that. Okay, 1 and 3, those are just constants. Okay, and we can just add those together. So we know that 10x, since we can't combine it with anything, is just going to stay 10x. Okay, but now we have 1 plus 3, which is 4. Okay, we have both pieces. Make sure when you're putting them together that you're not multiplying them, okay? Meaning you need the sign in between. So 10x with a positive 4, so plus 4. Okay, these guys are not like terms anymore, right? One has a variable, one does not, so that is simplified. Okay, let's look at number 5. So the difference that we see in number 5 that we didn't see in 2, 3, or 4 is that we now have parentheses. Okay, parentheses, so let's make this little note on the side of our paper. Parentheses tell us to what? Okay, what do we have to do with this 7 in front? Okay, we need to distribute, or in other words, multiply. Okay, it has to distribute to everything inside, meaning this 7 has to be distributed to both terms. Okay, when we distribute it, we are multiplying it. Okay, so let's go over here. Let's take our first piece first. We have 7 times 4x. Okay, so 7 times 4 is going to give me 28. There was 1x multiplied, so 28x. Okay, and again, 7 times just 4 this time is just going to give me that 28. Okay, so now we can put those two things together. 28x, it was a positive 28, so plus 28. Those are not like terms, so that is simplified. Beautiful. Okay, so number 6. Number 6, we are distributing, okay, because we see that this -2 is right in front, right? So it has to distribute or multiply to everything inside. Okay, so we have a -2 times 6a, which is going to give me what? -2 times 6 is -12, and then there was just 1a, so -12a. Okay, -2 times -9. Okay, remember we have to include those signs. Okay, so a negative times a negative is a positive. 2 times 9 is going to give me 18. Okay, so I have -12a with a positive 18. Those are not like terms, so that is simplified. Okay, so let's look at number 7. 7, 8, 9, and 10. Okay, our notes are a little shorter today. 7, 8, 9, and 10. Notice we have parentheses, but always look at the sign in the middle. Okay, so in 7, we are adding them. In 8 and 10, I believe we are subtracting them. Okay, so on the bottom of your paper, come here below 9. In fact, I'll zoom out so you can kind of see where I'm writing. Okay, let's make this note on our paper. When we are adding them, signs stay the same. Okay, and I'll explain this a little more in a second. Okay, when we are subtracting them, meaning when there's a subtraction sign in the middle, like on number 8 and 10. Okay, the signs change. Okay, so adding, signs stay the same. Subtracting, signs change. Okay, so let's look back at number 7. So I'll zoom it in for you. Okay, number 7. What are we doing? What is our sign in the middle telling us? Are we adding or subtracting? We're adding, right? So that means the signs after it only looks at the signs after. Okay, the signs in front of it will always stay the same. Okay, the sign in the middle, so addition tells those signs what to do. Since we're adding them, they stay the same. Okay, so now what we can do is really we can just identify what terms are alike. And in fact, to make it even easier, let's go ahead and rewrite it. Okay, so I'm going to rewrite this whole equation. Since no signs changed, all I'm going to do is just take away the parentheses. 1 minus 4v to the 4th plus 6v, okay, that's that first piece, plus 6v to the fourth, plus 4v minus 1. Okay, so that's our new expression, right? All I did was take away the parentheses because nothing needed to change because it was addition. Okay, so now we can say, where are my like terms? Okay, so again, remember, same variable, same power. So notice there are some variables with v's, but they might not be to the same power. So for example, I see a negative 4v to the fourth right there. The only other term that I can combine that with is this 6v to the fourth. Same variable, same power. Okay, so now let's just look at the coefficients. Okay, what is negative 4 plus 6? Okay, in fact, let's write it over here. So we have negative 4v to the fourth plus 6v to the fourth. What is negative 4 plus 6 going to give me? It's going to give me positive 2. So 2v to the fourth is that one piece. Okay, let's identify anything else that we can combine. So I also see a 6v right here. And the only other thing I can combine that to is that 4v. So what is 6v plus 4v going to give me? What is 6 plus 4? 10v. There's our next piece. Okay, now the last thing I see is this 1 minus 1. Remember, you have to always look at the sign in front. Well, what is 1 minus 1? Okay, 1 minus 1 is 0. That means we don't even need to write that. Okay, 0, we don't have to write. So our final answer, let's just take our two pieces that we have and rewrite them. 2v to the fourth with a positive, so plus 10v. And there's our simplified expression. Okay, let's look at number 8. What are we doing? What is our sign in the middle telling us to do? Okay, it's subtraction. And with subtraction, do the signs stay the same or do they change? Okay, remember, we're only looking at these signs after. Okay, subtraction tells us that the signs change. Okay, so we're going to go back up here. That means we can go ahead and rewrite everything, but we rewrite them with different signs. Okay, so you're always going to rewrite the first little piece exactly how it's written. That never changes. So 5n squared minus 7 plus 3n. Okay, here's where the signs change. So this was a positive 6n cubed. Now it's minus 6n cubed. This was a positive 5n squared. Now it's a minus 5n squared. This was a minus 2n. Now it is a positive 2n. Okay? So now that we've rewritten it, the signs have changed. Now we can go ahead and combine like terms. So let's see. I see the very first term I see is this 5n squared. Okay, what term can I combine with this 5n squared? Same variable, same power, says negative 5n squared. Okay, well, what is 5n squared minus 5n squared? What does that give me? Gives me another 0 again, so we don't even need to write that. Those just cancel out. Okay, let's look, find some other terms. So I see maybe this 3n right here. Okay, the other term that I can combine that with is the 2n, right? N to the first power, n to the first power. So I have a positive 3n and then a plus 2n, which is going to give me what? What is 3n plus 2n? It's going to give me 5n. Okay, so that's one of our pieces. Okay, what about this negative 6n cubed? Can I combine that with anything? Do you see any other n cubes? No. Okay, so this just stays negative 6n cubed. Okay, and our very last term that we haven't underlined yet is going to be this negative 7. Is there anything that I can combine the negative 7 with? Any other constants? No, so that also stays negative 7. Okay, so we have all of our pieces. Our 0 we don't need to write. We have 1, 2, 3 pieces that we now need to rewrite, just put together. So you always want to put your highest power first, okay? You don't have to, but you always, it's kind of a mathematical unwritten rule. Okay, it's called descending order, fun fact. Okay, so I'm going to put my n cubed first, so negative 6n cubed with a positive 5n, whoops, sorry, and then negative 7. Okay, none of those are like terms, so that is simplified. Okay, let's look at number 9. Okay, look at the sign in the middle of number 9. Sorry, this kind of went into number 9 space. Okay, what is it telling us to do? It's telling us to add. Okay, do the signs change or stay the same with addition? They stay the same. Okay, so we can always rewrite the first piece. Okay, that always stays exactly the same. So 3r cubed plus 5r squared minus r to the 4th. Okay, plus, because it's a positive, 8r squared minus 4r minus 4r cubed. Beautiful. Now we can identify like terms. Okay, so the first term I see is this 3r cubed. Do you see any other r cubeds? Yep, so there's this minus 4r cubed. So we have, what's 3r cubed minus 4r cubed? What is that going to give me? How many r cubes do I have? I have negative 1r cubed. Don't have to write the 1, so just negative r cubed. Okay, now let's see. My next term is 5r squared. Okay, any other r squareds you see? It's an 8r squared. Okay, so I have 5r squared plus 8r squared. So what is 5r squared plus 8r squared going to give me? 13r squared. Okay, beautiful. Now my next term, let's see, we have negative r to the 4th. Okay, are there any other r's to the 4ths? Nope. So that just stays negative r to the 4th. Okay, and our last term, it's not a constant, but we haven't combined it with anything. Negative 4r, so just r to the 1st power. Any other r's to the 1st powers? Nope, so that stays negative 4r. Okay, so we have all 4 of our pieces that now we can just rewrite together for our simplified expression. Start with your highest power because of descending order. So we're going to do negative r to the 4th. Our next highest is negative r cubed. Next highest, positive 13r squared and negative 4r. And that is our simplified expression. Awesome. Okay, last example for adding and subtracting polynomials. What is our sign telling us to do in the middle? Subtract, right? And do the signs change or stay the same with subtraction? They change. Okay, so you can always rewrite the first piece exactly the same. 4 plus 5n cubed plus 5n squared. Okay, they change, so this was a positive 5n, now it's subtract 5n. This was a positive 7n cubed, so now it's minus 7n cubed. This was a positive 4, now it's a minus 4. Okay, now we can go ahead, let's combine some like terms. So my first term is a constant, right? So I have just a number by itself. Any other numbers just by themselves? Yep, at the very end, that's just negative 4. So what is 4 minus 4? 0. Okay, that one cancels. We don't even have to write it. Beautiful. Okay, our next term is 5n cubed. Any other n cubes? Yep, right there. Okay, so I have 5n cubed minus 7n cubed, because it's a minus 7n cubed. Okay, what is 5n cubed minus 7n n cubed. It's going to give me negative 2n cubed. Okay, our next term is negative, or excuse me, not negative, just positive 5n cubed. Any other n cubes? Nope, nope. Okay, so we just have 5n, or not cubed, squared. 5n squared. Okay, and our very last term is negative 5n. And I don't see any other n's to the first power, so minus 5n. Okay, be careful here because you might think 5n minus 5n. Okay, they're not the same, right? This one is n squared, this one's n to the first, so you cannot combine them. So the only three pieces that we need to combine, put together, are those three, because we don't have to write 0. So our final answer, start with your highest power, so negative 2n cubed plus 5n squared minus 5n. And that is our simplified answer. Okay, notes are all done. They are linked on Canvas. Next up is your assignment. Thanks, guys.